Hi, welcome to day 3 of Build. Really excited to be here. Hope you're having a great time. Thanks for joining us. I'm Justin Cormack. I'm the CTO at Docker, and we're going to talk about all the things that Microsoft and Docker are doing together and how our ecosystems integrate and how developers are using Microsoft and Docker to work faster and more efficiently. Really excited to be here. We're going to talk about all our strategic investments, a bunch of upcoming innovations. We're going to show some things that we have never shown before in public, so it's going to be really exciting. Lots of demos, and so we're just going to talk about how we're unifying development with Docker and Microsoft, making everything work really well together, optimizing developer efficiency. We're going to talk about security because it's always important and it's always something that is becoming at the front of our mind. And of course, it wouldn't be a Microsoft event without talking about AI and the things we're doing with AI and the integrations we're doing with Copilot. Docker, is so well known, sometimes it feels it hardly needs an introduction, but there's always new people as well. But Docker is one of the most popular developer tools there is. From the Stack Overflow survey, we're pretty much every year with most wanted developer tool and most loved developer tool. Millions of developers use Docker every day and really love it, really improves their experience. And Docker Hub is this huge repository of applications to help you build your applications faster. And we're investing to make Docker even better and work even better with other ecosystems like the Microsoft ecosystem. We're all about efficiency. We're going to have some case study from one of our customers down here later, which is going to show you some of the examples in the efficiency. Delivering applications faster, more efficiently, more securely is really important. We're going to talk about integrating local and cloud together. And enabling you to innovate and putting AI in containers. And so we'll have a whole bunch of demos about AI as well. A lot of you will have heard of Docker, but you may not know that we have a whole suite of Docker developer solutions now. Docker Desktop has been around for a long time, really well loved. Often people's starting point and entry into the Docker ecosystem, running on Windows or on Mac or Linux. But most of our developers run on Windows. Docker Hub, as I mentioned, where there's images and content for building your applications. A huge library of trusted content for you to use. Docker Build Cloud is a new product we launched this year, which accelerates your container builds. It lets you have a shared cache with your whole team, which means everything runs way faster. We're going to show a demo of that a little later as well. Docker Scout is our security product, which we're going to talk about later. And also new to the Docker family is Test Containers Cloud. I know a lot of people use test containers. Test Containers Cloud accelerates your testing as well. So a whole suite of products, and more coming soon, which we're going to be showing you as well. Docker, it's Microsoft DevBox. We've got Anthony here from Microsoft to talk about this collaboration that we started very recently as well. Nice to see you.
How you doing?
Good.
See you. Yeah, I'm really excited to be here. Thank you, Justin. I'm Anthony Cangialosi. I'm the Group Product Manager for Microsoft DevBox. And excited to be here with Docker, a company that really truly knows what it means to deliver rapidly development environments into the cloud. I'll tell you a little bit about Microsoft DevBox, which are cloud development environments or environments that you can spin up instantly that are ready to code, available in Azure. They provide or can be configured to have all the tools that you want for your team into the environment. These can include your source code, your developer tools, your packages and build environments. Imagine the largest applications you're building being able to spin up those environments in just a few minutes. You can do this now through a new imaging service that we're building into the DevBox service. This really democratizes for any team the ability to create, through config as code, a development environment for every single project in your organization. Now you can spin up and manage them with your code in the repository, so team members themselves manage that along with the lifecycle of the application. They're very much project scope, but they're also very personal. So your developers themselves can also configure those environments for themselves with their own personal tools, their own personal settings, tabs for spaces, dark mode, light mode, whatever you want. And then finally, they're built on top of Windows 365. So they're managed and integrated with Intune. They're domain joined, so they have all the same policies and config as code, or I'm sorry, excuse me, conditional access policies that you manage for your enterprise.
Thanks.
Thanks,
yeah, we're seeing so, we're going to talk more about cloud or local and giving developers the choice, giving organizations the choice later on. It's a really important, having the options to choose how you want to develop at different times or different places.
Yeah, they have all the tools that they need, including Docker, and they have images available on the marketplace that have Docker built into them. So Docker is pretty much available everywhere. Thank you.
Thanks. So that's just one of the many examples of Docker and Microsoft better together. I mean, there's so many areas that we're integrated. I think so many of our customers use Azure Kubernetes Service. They use the Microsoft Container Registry, obviously VS Code. 2 days ago, we launched the Docker Desktop on Windows on ARM, which so many people were so excited about. I can't believe how many people have asked about this and tweeted about it, and people have been waiting for that for so long. People excited about new laptops, new opportunities, new architectures, new fast Copilot Plus PCs. So that's been really exciting. Obviously, we have really deep integrations with GitHub, with GitHub Actions for Docker build, and all sorts of areas. So, and Docker Build Cloud enhances the Azure DevOps experience. So we're very closely integrated across our all our products, and this is really deepening. And as I mentioned before, we're local or cloud are your choice. You can choose devbox, you can choose local, you can mix them at different times. Your organization can choose, and all of those, you still get the same experience with VS Code, with WSL2 and the Windows experience, like wherever you choose to run your code. Docker Desktop, Windows on ARM. Can't repeat it often enough. It's been really exciting. I actually we started looking at this years ago. I had a Windows on ARM machine like maybe 5 years ago, and but we didn't have the full Docker Desktop experience then, and now it's the full desktop experience, which is really, really great. We've been optimizing WSL2 and improving the performance on WSL2. And we also have Docker Desktop available on Red Hat Enterprise Linux. Again, you can run that in the cloud or locally. So that's another place it's become available just because customers have been asking for all these choices. Now, this is another thing that, again, there's been a lot of work behind the scenes for a lot of times. BuildKit is our next generation Docker build that we've been working on for quite some years now. But one of the issues with it was it didn't support Windows containers for a long time. But we started collaborating with Microsoft to actually fix that and fix the gaps in that. And this is actually in preview right now. And we have a demo from Colin, who's actually over here, confusingly.
Hi, I'm Colin, product manager on the core build team at Docker. Today, I'm excited to share with you new support for Windows containers within BuildKit. This is an ongoing collaborative effort between Docker and Microsoft to improve the experience of building Windows containers. So before the introduction of BuildKit, we had the classic Docker builder, which did a great job of building container images, but it had several shortcomings, such as builds were sequential and unoptimized, meaning that more work was done during a build than was necessary, which resulted in a slower build experience. There was no built-in support for building multi-platform images, and caching and cache management was somewhat limited. BuildKit is the new build engine in Docker as a solution to these issues by parallelizing build stages to improve build speed, automatic build optimization to only execute the build stages that are targeted and only move files needed in the container image, as well as adding support for build emulation and builder configuration to handle building for multiple platforms within a single Docker file or build command. And finally, adding advanced cache management for build layers and packages to dramatically speed up execution between build iterations. There are so many improvements that come with BuildKit that we could spend hours just covering them all. But today I'm excited to share the beta release of BuildKit for Windows so that you can all get the benefits of BuildKit when building Windows container images. Let's see how it works. So now if we jump over into Docker Desktop, we'll see this all working. So as previously mentioned, one of the benefits of BuildKit is the ability to switch between multiple builder configurations as you need them. So if I select for builder settings, I can start to configure those. So here we can see we've currently got the default builder selected, which is the one that we use most of the time. But if we scroll down here, we can see that I've previously set up a Windows builder, so for building Windows container images. And this will be running against the BuildKit for Windows. So I can just switch to that by a simple click, and that's done. Setting up these builders is really straightforward, and it's all covered in the documentation. But yeah, I set that up ahead of time just to save some time there. Jumping over into VS Code, here you can see that I've created a basic Docker file for building a Windows container image. You can see we're using a Windows base image, and we're copying in a file, making some amendments. So we can execute that build with this standard build command in Docker. And here we're going to build that image, we're going to tag it, and then we're going to push that up to the hub. And you can see that's completed. We can see it's been pushed up to the hub, and you can see that we've taken advantage of the cache there because this has been an iterative build. And now what we're going to do is we're just going to run that image to show that working. So here you can see that we are just extracting, pulling that down from the hub, running the extraction, and then it will execute that build once it's completed downloading. And it was as simple as that. It's all running, and we can see hello from BuildKit, installation is working, and we're running that from Windows. And so that shows, yeah, building a Windows container image and executing that. But it's a fairly basic setup, so I think we can do something a little bit more advanced. So if we jump back into Docker Desktop, what you might have previously noticed is that we've got a list of builds here. So you can actually inspect these builds within Docker Desktop, which is great for debugging and trying to do optimization and really understanding what happened at build time. And this is available for Linux and for Windows builds now. But again, if we jump into the builder settings, and what we can see is I've also previously configured a builder for building for multi-platform. Again, really straightforward, but I've just done it ahead of time to save some time there. You can actually inspect these builders in Docker Desktop to see more information about the configuration. Here you can see we've got multiple nodes, one for Linux and one for Windows there. So now if I head back over into VS Code, what I've done is I've set up a Docker file for building a multiple platform image for both Linux. That will support both Linux and Windows. And this takes advantage of some of the great configuration and power that you get within BuildKit, that you can define these runtime, these build time variables that will help you configure your build, and you can build in certain inheritance and things like that. So it really reduces the amount of configuration you need to define for building different images, and you can put it in one location. So now what we're going to do is we'll just build that image, and I'll walk you through here. So again, we're just going to build the image, we're going to tag it, we'll give it a different image name as part of that tag, and we will specify the Docker file. This is just because we're giving it a different Docker file name. If you just call it Docker file, then you wouldn't need to specify that. And then this is as simple as it gets, really. So to build for multiple platforms on BuildKit, you can just specify this platform option, and here we're going to build for Windows AMD 64, Linux AMD 64, and we'll build a Linux ARM image while we're at it. This is taking advantage of multi-platform builders and also some builder emulation in there to, again, make this as simple as possible for you to build. And so we're just running that build there. You can see that building and pushing up to the hub, and we're complete. So I can run that build within this terminal within VS Code here, but I'm actually going to switch over to a PowerShell terminal. So here we're just in a standard PowerShell terminal, and what I'm going to do is I'm going to run up that image that we just built. So here you can see it locating that on the hub, pulling it down, extracting, and executing. And as part of this this particular builder configuration, you can see the output. We've got the Windows specific command that we run in there, and the message that we supplied as part of the Windows build configuration. What I've also done is set up a Ubuntu image using WSL, and what I want to show you here is we're going to run the exact same build run command for the exact same image, but we're going to run it in a Linux VM. So here it's pulling down that image again, executing, and again we can see the output is executed successfully, and we've got the platform-specific configuration and commands being run. And so this is really powerful. You can show that you can build for different platforms, and you can keep your configuration concise and in one location, and all managed from there. So that about wraps things up. So this is the beta release of BuildKit for Windows. This is available now. You can install that, try it out. Early access with built-in support within Docker Desktop will be coming soon. And yeah, just to recap, BuildKit aims to provide this consistent build experience across platforms, increasing build efficiency and providing support for Windows developer community. Back to you, Justin.
Thanks, Colin. Next, we're going to talk about the inner loop. With the inner loop, I'm not sure everyone necessarily knows what that term means, but the inner loop is where you do your daily work, where you're sitting there, you're editing, you're building, you're testing out stuff. You're really in the flow. The outer loop is when you push things to CI. And the worst developer experience is when you push things to CI and then you wait 45 minutes and then it tells you something went wrong and you have to kind of go back. And I've worked in environments like that and it's kind of horrible. At Docker, we're really trying to help you get everything right in your inner loop, fast, conveniently, and in a nice way, so that when you push out, things can go straight to production. Straight to the things work. Things behave as you expect, and we'll talk about that more with things like security as well as inner loop development. Our product suite actually spans across, everything we build runs across inner loop and the outer loop. So things like Build Cloud let you build faster locally, and then also accelerate the outer loop after you've built it fast on the inner loop. So we span both, but we're really trying to bring everything into the inner loop to make things as fast and as efficient as possible. One thing that we're actually GAing in the upcoming 4.31 release of Docker is Docker Desktop Debug. This is a tool we built for making it easier to work with container images. It lets you install a whole bunch of extra tools in the shell inside an image dynamically at runtime, so that instead of having to rebuild an image with more tools, if you want to do some debugging, you can just add them like on the fly without actually changing the image, so that you can debug more efficiently. It also has other features for debugging stop containers and so on. That's all part of the Docker subscription in 4.31. We're also excited to share new things we've been working on around cloud engines and hybrid clouds, or working in the cloud. And we actually have never shown this before. Rodney here is going to actually demo this live. This is the first time we've actually shown this in public. So this is going to be in preview soon. It's in internal development at the moment. So really excited to have Rodney here to show this.
Thank you, Justin. Let me switch this here. So this is the first time that we're going to be doing a demo like this. This is a project that we started a while ago to improve the inner loop. I hope that the demo goes hard with me today, because still literally is in the works. So the goal is conceptually simple. We want to allow developers to use cloud infrastructure. We want to do that in a really simple way. And we don't want to go down the approach of having to move the user to the cloud. We want to meet the users where they are today, which is, for Docker case, their desktop, their laptops. So our approach is going to be based on that. We want to make sure that they keep their UX the same way that they're using it today. They can use their IDEs, their debuggers, their tools, their terminals. So we don't want to change any of that. So this approach is kind of a hybrid, as you can tell. So if we want to make this work, we have to figure out a way to split the client side from what it would be the server side. Server side would be kind of running in the cloud. So all the workflows will execute on the cloud, but they still will keep, kind of the UI section, on their laptop, so they can keep on using their tools. So let's see how we do that. Let's do a quick demo about how that will look like. So this is Docker Desktop, what you're looking at right now. We're going to have a new section. This is the placeholder, the name right now, Harmonia. It's kind of the internal project. It's going to have a different name. So what we're going to be doing here is we're going to allow the user to create these cloud engines. Obviously, we'll execute in the cloud. And let's see what is the interface that we're offering to the user. So it's going to be very simple. You're going to type your engine name. I call it my engine. Obviously, you're going to set your your corporation, your org, and you're going to be offered a template with options. You can pick this set of options. Eventually, we'll have much more. Let's go with a simple one. I want a cloud engine that is hosted in an environment that consumes or that takes no more than that. I'm going to also be interested in syncing some of my files upstream, right? So in this case, I've been working on an application that is a sample voting app, probably a bunch of you already know. And I'm making changes to that app. So, because I know that I'm going to be changing that, and I'm going to be executing containers that will look into file systems in that space, I'm interested to tell this cloud engine, hey, ahead of time, go ahead and synchronize data to the cloud. Okay, so the last switch is very simple. It's just saying, hey, you know what? When you've done created this context, this environment, this cloud engine, go ahead and switch to that. You could have multiple of those environments, not that you're going to have one. Let's just go ahead and create that. So it's going to take a few seconds. If everything goes right, shouldn't be more than 10 seconds. So in parallel, I'm going to be bringing my terminal here. Okay. And I'm going to ping Docker. I'm going to ask for the context that have been created in my environment. I'm still running default context, which is desktop Linux, so nothing has happened yet. The system is still creating this instance. It should be created by now. Work in progress. Let's go back here. Let's switch to it automatically. Okay, let's take a look now. Okay, so you see this in my engine, cloud engine, or Docker engine, if you will, that has been created on the cloud. So from this moment on, everything that I do with Docker in my computer is going to be executed on the cloud. Even though I still keep my UX, I still keep my tools. I haven't moved. I'm still on that same framework that I was before with my terminal. Nothing has changed. So let's bring this environment up, this set of containers of this app that I'm talking about. So if we do things right, nothing has changed for the user. I'm insisting on that because that's a really critical point. This is a regular Docker compose. It will take a few seconds to come up. There's like 7 containers in this application. In the meantime, let's get to Docker Desktop to see how images are being pulled. See, we already have Postgres, we already have Redis. As you can imagine, I think we're downloading around 1 gig right now of data. Looks like we have a little issue here. Yeah, demo gods are not with me, as I was afraid of. So the important thing here is that I'm running on a Wi-Fi right now, and I'm downloading 1 gig. But that 1 gig is not coming to my laptop. The reason I'm able to instantiate this when it works in a few seconds is because the content is being downloaded from cloud to cloud. I'm talking to my engine on the cloud and tell, hey, engine, pull this data for me and synchronize everything so that everything works for me. So that's what I'm able, in principle, to instantiate all this in a matter of seconds. So that's the key. The savings that you see based on the fact that you're not consuming the bandwidth from your laptop to the cloud. So let's see, how can we do from here? Yeah, for some reason we run into unexpected issue here. Not sure what happened, to be honest.
I
can barely hear you.
Yeah, so it's totally transparent. It's the same experience. You can just use the cloud for pieces of your work, especially if you have things with large data sets or you need GPUs, or you have applications too big to run on your laptop, or Yeah, the feel of it's still local. So it's this very much a hybrid thing. You don't have to change the way you work. You've still got your local files, your local editor, but it's just transparently in the cloud, and that's really powerful.
So the demo that I had ready is not going to work, but I'm going to be using a few seconds more just to show you that this principle really works. So I'm going to create a container. You can see there. That is a container with 1,000 GNX. Gosh, yeah, that's not going to work, that terminal either. Yeah. Never mind. OK, so just to wrap it up, the value that we're seeing here is not only the fact that you're offloading resources to the cloud. The value also comes from the fact that now you can share things, because all of a sudden you're putting something in a centralized location. That centralized location allows you to interact with other applications that are already in the cloud, with other users. Users all of a sudden now talk to that engine. They can access an environment that is remote, is in a centralized location. So I wish that I could show you how that works, because it's that simple. With Docker Desktop now, once that you have the application running, you click on a port, and that cloud engine is not only taking care of syncing the files, but also takes care of sending your traffic locally to the cloud engine, so that your applications are executing like if they were here locally, pretty much exactly the same way. And that allows other users from your team to access that cloud engine, to access the same applications in exactly the same way that they were locally present. So that's one critical point, and I think I'm out of time, so I'm going to hand it over to Justin.
Thanks. Well, I mean, live demos of pre-release things don't always work, but thanks for trying, and it'll be working for the release. But we're really excited about this. I mean, we really like this hybrid model, because it just gives you that flexibility to choose what works, but with the same developer experience. Next, we're going to go on to security. Security is really important, and again, with the focus on the inner loop, again, the worst thing that can happen for a developer, you're building your application, everything's ready to go, you've run it through CI, you want to ship it to production, and then your security team tell you, oh, sorry, there's some vulnerabilities you have to fix, there's things you have to do, and it slows you down. So we really want to shift this stuff back to the developer, back to the inner loop, so you can fix the stuff as quickly as possible, but with the right focus. We really want to discover vulnerabilities as soon as possible, and give you recommendations, right in the IDE, right on the desktop, about what needs to be fixed, so that when you actually push through the outer loop into CI, everything's fine. You can go to production straight away. So Docker Scout, which is our security tool, provides you advanced image analysis, like right on the desktop and in your container registry in Azure or whatever, and it can give you kind of live updates. You don't have to rescan images. It just makes an index once, and then it can give you updates when a vulnerability happens later on. Can give you alerts. So it's the workflow is very much designed for that fast feedback, live updates whenever things actually happen, and then it gives you recommendations for exactly how to fix things, exactly which image, whether it's from your application image or the base image or wherever the thing's coming from. It tells you which part of it you need to fix, so you can really make informed decisions quickly and fast. Security vulnerabilities can be really difficult to deal with, and it can be a very difficult communication thing between the security team and the development team, and we really aim to shift it so that developers can action things easily and quickly, and help the security team. We prioritize things based on relevance and severity, so we can prioritize the most important things, and we can actually have customized policies set for your organization. So your organization can set policies on things like vulnerability remediation times, licenses, software licenses for packages you're allowed to use, and things like that. And we can continuously evaluate those policies, and again tell you right in the desktop or as early as possible, even like in the IDE. We're doing a bunch of IDE integration into VS Code for this so that it can tell you to fix things really, really early on and set these comprehensive security policies that your organization can customize and set to what makes sense for your organization, and basically customize the whole Scout system to your organization's policy. So this is really designed to be really flexible and easy for developers. And it's integrated into all the tools you're already using. It's integrated into Docker Hub or into Azure Container Registry, into your Azure pipelines and GitHub Actions. So there's a whole set of integrations around the whole Microsoft ecosystem to make this work more efficiently. And we're going to have a little demo of this from Christian.
Hello and welcome to this quick Docker Scout demo. In this demo, I want to demonstrate how to use Docker Scout to analyze local and images pushed into a Microsoft Azure Container Registry. Let's jump in. This is the Docker Scout web dashboard. You can log in using your Docker Hub ID, and after logging in, you'll see the results of the Docker Scout out-of-the-box policies. We have policies for license compliance, vulnerability compliance, and other aspects of supply chain security, such as running images and non-root users, supplying all best practice supply chain attestations like SBOM and provenance, or lastly, everything around base images, so making sure that you're always using up-to-date and not outdated or deprecated base images. But before you can start using Docker Scout on Azure Container Registry images, you have to integrate a Azure Container Registry. You can access the Azure Container Registry integrations by clicking on the Integrations tab on the left-hand menu, locate the Azure Container Registry tile, and click on Manage. In your case, you would have a wizard here to guide you through the connection process of an Azure Container Registry. In my case, I did this about 9 hours ago, and I'm connected to MS-build Azure ECR.io, which is my demo container registry. Over here in the Azure portal, I see that that container registry contains a front-end repository with a main tag. And that's the image that I want to use in this demo. So heading over to the Images tab in Docker Scout, and after configuring the integration, I can see this particular tag, the main tag, now being brought into Docker Scout. And I see also that Docker Scout has analyzed this image for vulnerabilities and other compliance aspects. And I can drill in to see the particular results and details about kind of like the compliance state of this particular image. I see that that image has a couple of fixable critical high vulnerabilities, and it is also using an outdated base image. So next step in this demo is to show you how you can use tools in your inner loop on your laptop to address these two security reports here. So let me head over to the terminal here, and this is the Git source of this particular sample project that I'm using in this demo. And I can use now on my laptop the Docker Scout quick view command to look quick view ms build Azure ECIO front end main. I can now use the quick view command to quickly look at the image on my laptop here. And this gives me kind of a couple of really interesting information. I have this little checkbox here, checklist here of things that I can do locally with my development tools to address these security reports. So for example, there are still a couple of fixable critical high vulnerabilities that I want to address, and I want to definitely take care of the outdated base images that I'm using. Jumping right in, base images, I can drill in a little bit further and take the Docker Scout recommendations command as suggested down at the bottom here and get very detailed recommendations on what to do with my base image. So currently I'm using Alpine 314. That was apparently pushed 2 years ago. It seems fairly outdated. And Docker Scout is now giving me, based on what I'm using right now, it recommends me a 319 tag. And that would remove a couple of vulnerabilities. It's also a lot newer, so contains a lot updated packages and a lot of the CVE fixes that I'm trying to apply to this image. So heading into VS Code and opening up the Docker file gives me some really interesting information here. So this is the Docker VS Code extension with some special Docker Scout integration. And I can hover the from line here and I get recommended tags. So bringing the same information that you saw on the CLI into an IDE, really where developers live each and every day. So I can now go ahead and say, I want to apply the quick fix to update to 3.19. Going back to the CLI now, and I can quickly use a Docker build command to run a local Docker image build to verify a couple of things. First of all, that I didn't break the image, and secondly, that I actually fixed the security concerns. So I did run the image build now, and I want to bring in Docker Desktop to show you how Docker Desktop integrates Docker Scout to kind of really visually represent the composition of an image, helping you to navigate the different layers and different aspects of a container image. So you can see by upgrading our base image, we fixed all the vulnerabilities. This is indicated by these little green check marks. And if I go over to the packages tab, I see the various kind of like packages all coming from our SBOM that we produced during the build. So in this demo, I showed you really quickly how you can use the Docker Scout Azure Container Registry integration to bring in images from Azure. And I also showed you how you can use Docker Scout tooling in the CLI embedded in Docker Desktop to address common security concerns and policy violations very quickly and efficiently.
That's great. So I've talked about a bunch of stuff, but there's nothing better than having customers. And we've got Alan here, who is from JP Morgan, who's actually here live to talk about their experience accelerating application delivery from months to minutes. And this is a sort of story we'd love to see. So Alan's going to be at the booth later.
Hello, I'm Alan Torrance, Head of Open Source and Developer Productivity for JP Morgan Payments. Today, I'm excited to share a demo, Building Faster Together, using GitHub, Copilot, and Docker with JP Morgan Payments APIs. I'm hoping this educates and entertains, but also illustrates the power of speeding up the developer's inner loop by integrating JP Morgan Payments APIs with Docker alongside GitHub and Copilot. We create an environment that accelerates the software development lifecycle process. Let's look at what this means. We are able to help accelerate application delivery from months to minutes by improving this inner loop around the SDLC for developers. In the design phase, we provide open access to our APIs on the Payments Developer Portal. In the testing phase, we leverage Docker Desktop and Docker Hub to test locally and share common images. In the implementation phase, we leverage GitHub Copilot AI to accelerate our coding and testing. This is the key in a loop for every developer. Let's take a closer look at the tools I mentioned. Firstly, Docker Desktop, that provides a way to share and run secure images locally. Secondly, Payments Developer Portal, that provides access to the APIs and documentation we need. And of course, GitHub Copilot, our AI assistant that will accelerate each step from within our IDE. Let's set up a simple use case. This use case represents the many ways today that we use Docker internally and externally. We created a retro game where you can earn some coins. We then created a swag shop with an online payments API where you can exchange your in-game coins for swag. You can probably tell I love retro games almost as much as I love great swag. Again, this simple use case illustrates one of the many ways we use these great tools to help accelerate our SDLC in our loop. So that we are using some real APIs, let's use online payments from JP Morgan. What I do here is navigate to JP Morgan Payments Developer Portal. From here, I can explore the APIs and documentation. I'll take the online payments API shown here. I can now get started with my swag store quickly. Okay, let's get some code. JP Morgan Payments has a GitHub presence. On here, I can access lots of showcase applications and integrations to get me started quickly. I can view and check out some code directly into VS Code IDE.
No, I know.
To highlight our use of AI, here I am in VS Code. GitHub Copilot directly links into my IDE. I can quickly and correctly generate the code I need, in this case, a simple React component for loading. And we are done. It's that simple and quick. Now for the real magic. Let's download some secure images from Docker Hub, searching for JP Payments from within Docker Desktop. It is that quick and simple. Let's take a retro game, for example. I can set a port to run it locally. And just like that, we have a retro game downloaded and running locally. Superb. It gets better. All of my team can easily download these same secure images and run them locally, all accessing the same version from their laptop or virtual desktop, thanks to Docker Desktop. It's that easy. Let's not stop there. By using Docker, we can deploy these images onto Azure or any cloud provider. It just works consistently. Let's recap. We have used Docker Desktop and GitHub Copilot as part of our inner loop, or SDLC, to quickly and simply iterate on a use case like we do every day. This shows the art of the possible, what we can achieve when we work together, helping reduce application delivery from months to minutes. Thank you.
Thanks so much. Now we're going to talk finally about Gen AI. We are today introducing the Docker extension for GitHub Copilot, which allows you to talk to @Docker in GitHub Copilot chat and learn about how to build Docker tools, how to generate Docker files and compose files, and how to find vulnerabilities with Docker Scout. So it integrates all our tools together in Copilot. We've just got time for a quick demo, I think.
So I'm on github.com and I've got a repo with a React front end, Spring backend, and a MySQL database. This repo isn't yet containerized, but Docker can help us with that. The Docker extension for GitHub Copilot is helpful for existing Docker users and folks looking to learn about containerization and get started. So let's start by asking @Docker about containerization. So I'll type @Docker, can you tell me about containerization? What are its benefits? And so it looks like it's printing out a bunch of different benefits of using containers, which is awesome. And that all sounds super useful. So let's ask the Docker extension for GitHub Copilot to containerize our app. So I'll type @Docker, can you help me containerize my app? So let's see what it did. So, okay, oh great. It generated a couple of different assets and also provided us with some explanation of what each file does. So we have a Docker file for each of our services. So we have one for our front end and one for our back end. And it looks like it also successfully detected the languages for each of our services. So, and if we click into these, we can also see that each of the files is using a multi-stage build, which helps with both optimizing things and improving the overall readability and maintenance of each file. So that's awesome. We also have a Docker Compose file, which is really great because that'll help us spin up our app end-to-end in containers, which is really nice for our local development scenario. Oh, and it looks like the Docker extension for GitHub Copilot is also asking me if I want to open a PR. And so I'll say, yeah, let's open a PR. And so it looks like it opened a pull request for us with these assets. We have a nice pull request comment here, which helps us orient ourselves. And then if we click in to see the files change, we can see that it added 2 Docker files, one for our front end and one for our back end, a compose file, and a couple of Docker ignore files, which is awesome. But let's imagine that I'm new here, and let's see if Docker can tell me about how to use these files. So I'll type @Docker, how do I use these Docker files in the Docker Compose YAML file?
So you see, it can help you there, help you with building the Docker files and so on. So it's really, really helpful. That's in preview now. You can sign up for the beta program, and it'll be out later on. And so, sign up and check it out now. We don't have time to show you the full Gen AI stack, but we will be showing it at the booth. This lets you create RAG applications in Docker really, really quickly. Rodney was going to do a demo, but we don't have time, but it's really, really effective and quick. So we'll skip that demo. So better together story, as you can see with Docker and Microsoft, really strong. We work very closely with Microsoft. We're building all these great tools together to accelerate your development flow. Check out Docker 4.31, which has all these previews in. The ARM support is there. Come to our booth and we can show you all these demos, more demos. Alan from JPMorgan will be there. And so it'd be great to see you there later on today. Thanks so much.